Alright, how's everybody doing out there today in the world of Math Magic Land? That's right, it's Mr. Muscarella coming at you, and today we're going to take a look at the third type of solving logarithmic equations, ones that involve quadratic expressions. But first, let's just kind of review real quickly. Remember, the domain for the log function is that x's have to be greater than 0. So think about that from both the graphical perspective when we take a look at the picture, but we are going to be looking at things algebraically. So we've got to remember that the domain for x has to be greater than 0. Now, check out this lovely little equation. We get log base 4 of x plus log base 4 of x plus 14 equals log base 4 of 51. Now notice this time we've got a plus sign in between log base 4 of x and the log base 4 of x plus 14. So that, boys and girls, remember, is going to imply multiplying. So we're condensing this so that we're going to have log of x times x plus 14. So we're going to multiply those two pieces together, and we know that that's going to be equal to log base 4 of 51. Now when you distribute the x there, of course you'll get x squared plus 14x. So we're going to have log base 4 of that is going to be equal to log base 4 of 51. So since both sides have log base 4, we're going to go ahead and get rid of that by exponentiating both sides, but we're going to go ahead and just set x squared plus 14x equal to 51. Now this becomes a quadratic equation that we're going to have to solve. So we're going to have x squared plus 14x minus 51 equals 0. So we're going to have to take our time and find the two correct factors of 51, negative 51, that give us a sum of 14. So let's just kind of go through that. Get 1, negative 51, we know that's not going to be it. Even if we flip the signs around, that's still not going to be it. But 3 goes into 51 17 times. So if I have 3 and negative 17, that gives me a sum of negative 14. So I know that I have to just flip them around. So this quadratic is going to factor into x minus 3 and x plus 14. Set that equal to 0. Now you could have also solved that using quadratic formula if you so wanted, or there's other techniques, but we're going to use factoring since this one factors. Now of course we set each factor equal to 0. So now we get two distinct answers after we set each factor equal to 0 and solve. We get one value where we have x equals 3 and the other value where x equals negative 14. But remember, we've got to go ahead and double check to make sure that these are possible solutions. So if we were to plug these numbers back in for x, anywhere there's an x, we would have to take a look at it. And remember, that piece right here, this x, or the x plus 14 part, that has to be positive. That's got to be greater than 0. Now, of course, if I plug in 3, 3 is definitely greater than 0, no matter which one of those I plug that in. However, when I plug in negative 14, that is not greater than 0, and the first part, log base 4 of negative 14, that is not a possibility, so that does not work. X equals negative 14 does not work. That's one of our extraneous solutions. So thanks for playing, but no dice for you, negative 14. So the only solution for this is x equals 3. So here in example 2, we're going to have something very similar. Log base 2 of x plus log base 2 of x plus 4 equals 5. Now notice on the right hand side, there's no log. So this one's going to be handled a little bit differently, but we're going to go ahead and we know that we're going to combine these two terms. So we're going to do that actually in one step. We're going to have log base 2. If I were to distribute x to the x plus 4 quantity, that's going to give me x squared plus 4x. And that's going to be equal to 5. Now, in this situation, what you want to do is we're going to use properties of logs because we know it's log base 2. So that means we're going to have the base is going to be 2, but our exponent is going to be 5 over here because we're going to take this and we're going to rewrite it. Log base 2 to the power of 5. So we're going to have x squared plus 4x equaling 2 to the 5th power. Now you should know 2 to the 5th power is, of course, 32. So x squared plus 4x is going to give me 32. Now this is where we're going to move the 32 over and set up a quadratic. From here, you have a lot of techniques that you can use to solve, but we're going to go ahead and use factoring because this is going to factor into x plus 8 and x minus 4 equaling 0. Of course, you'll set each factor equal to 0 and solve, and then check our solutions. Now the two values that we will get for x are x equals -8 and x equals 4. We've got to put those back in to double check and make sure that they both work. And remember, x has to be, the piece on the inside has to be greater than 0. So if we plug in -8, that is not going to be happening, because log base 2 of -8 is definitely that -8 is less than 0, so no dice for you. But if we plug in 4, 4 works in both of them. Thank you very much for playing. 4 is our only solution. Alright, that's it for this video. Thank you guys for watching, and by now you should understand how to solve logarithmic equations where you're going to involve quadratics. Have a great day, guys, and peace out.